There are two functional groups that we're going to look at in this video. One is alcohols and the other is carboxylic acids. Alcohols have got an OH group on them. It's not the same as a hydroxide group. It is called a hydroxyl group. And we name alcohols by ending with the suffix -ol. The alcohol group will always get the lowest possible number in terms of the lengths of the chains. So between alcohols and carboxylic acids, you just take an alcohol, you oxidize it, in other words, add a little bit more oxygen to it using potassium dichromate and an acid, and you will get the corresponding carboxylic acid. So this is an alcohol with only one carbon, we call it methanol. This is an acid with only one carbon, carboxylic acid with only one carbon, and it is called methanoic acid. Here we've got two carbons, ethanol. Oxidize it in the presence of a strong oxidizing agent such as potassium dichromate, and you will get two carbons, and noic acid. This OOH reminds you that you've got an carboxylic acid. So it's ethanoic acid, methanoic acid. So alcohols are easily oxidized into carboxylic acids when treated with a strong oxidizing agent. Alcohols are amazing molecules. Why? Because they have got a polar part and a non-polar part. This means that they can have London forces and they can have, actually they have hydrogen bonding and dipole-dipole forces. So it means that they'll just dissolve and interact with a lot of different substances and make lots of different mixtures. Alcohol molecules have got non-polar hydrocarbon ends and a polar OH section. Alcohols are therefore solvents for polar and non-polar solutes. First, we're going to have to draw these different alcohols over here. So hexanol has got 6 carbons. 1, 2, 3, 4, 5, 6. And then, I suppose we should have said hexan 1-ol, 2-ol, but you can default it to the end of the molecule if nobody bothers to tell you anything different. Don't forget to fill up with carbons, at least hydrogens. You will lose marks if you do not put all of your hydrogens in. The next one is butan 2-ol, 1, 2, 3, 4. On the second carbon, you put the OH group, and then you only fill up the rest with hydrogens, making sure that every carbon has got a valency of 4 and is therefore bonded 4 times. And finally, 1, 2, 3, propan-triol, prop 1, 2, 3, triol OH, and 1 on the 1, 1 on the 2, and 1 on the 3, and then fill up the balance with hydrogens. So there's 3 prop, triol, 1, 2, 3 of the alcohol group, and where are they? On number 1, 2, and 3. If I were to have to draw out or name butan 2-ol, here it is, and here's your propan 1, 2, 3 propan triol. Compounds that have the carboxyl COOH functional group are called carboxylic acids, and they end in anoic acid. They are relatively weak acids. If we start asking you questions in acids and bases about them, you're going to have to know that they are organic acids which are weak. Butanoic acid, 4 carbons. The last carbon has a double bond OOH on it. That is the ethanoic, at least that is the carboxylic acid group. And then we fill up. Take note, this carbon has a double bond over there, so there are 4 valencies from that. If I were to name it, 4 carbons and the carboxylic acid group, so it's anoic acid at the end.